the most important topic, that is divisibility rules in number system. Divisibility rules is an extremely important topic for any student who is writing competitive examination where number system is a part of it. Today in this class, we will discuss the divisibility rule for composite numbers. We will also discuss the divisibility rule for prime numbers, that too especially for a single digit prime numbers, that is 2 and 3 and the next one is 5, right? And the divisibility rule for prime numbers like 7, 11, 13, 37, 27, right? All will be covered in the next coming classes. Extremely important class. At the end of the class, you will be able to understand how to develop the divisibility rule of a composite number by using these prime numbers. Always remember, every composite number is nothing but a product of prime numbers. Any composite number can be written as a product of prime numbers or can also be written as an power of prime bases. Prime number is a basic entity, composite number is a derived entity, right? Now for example, suppose if it is 12 is there. 12 is a derived entity. It is derived from 2 and 3 prime numbers. So it is 2 square into 3 power 1. 105 is nothing but 3 into 5 into 7. Every composite number can be written as a power of prime bases. I will come to this point. I will start from an elementary basics onwards. Slowly, gradually, problem by problem, I will increase the level of difficulty in the question. At the end of this class, you will be able to solve the elementary questions based on the divisibility rule for unit digit prime numbers like 2, 3 and 5 and the divisibility rule for a composite number. Without wasting our time, let us first get into the concept. Suppose for example, let me take a key point 1. Suppose there is a 2-digit number xy. For example, it is 23. 2 is there in tens place. So it is called as 2 into 10 plus 3. Because 2 is there in tens place, the value of 2 became 2 into 10. Suppose if it is 179, 9 is there in units place, 7 is there in tens place, 1 is there in hundreds place. Because 1 is there in hundreds place, the value of 1 became 1 into 100. The value of 7 is there in tens place, so it is 7 into 10. Plus 9. I hope the idea is clear. If 7 is there in tens place, the value of 7 is 70. If 1 is there in hundreds place, the value of 1 is 1 into 100. With this understanding of the question, let us take a 2-digit number x and y. Y is there in units place. Y is there in units place. And x is there in tens place. X is there in tens place. Because x is there in tens place, the value of x became 10 into x plus y. I hope it is clear. Similarly, if it is a 3-digit number, x, y, z. Z is there in units place, y is there in tens place, x is there in hundreds place. So the value of x will become 100x plus 10y plus z. I hope the idea it is clear. This is called the units place, and this is called the tens place, and x is called the hundreds place, x is called the hundreds place. Why it is called a tens place? These 10 power 0, these 10 power 1, and it is 10 power 2. Why? Because xyz is written in base system. It is written in base system 10. Because it is written in base system 10, starting from the right hand side, right, it will be 10 power 0, next it is 10 power 1, and next it is 10 power 2. Are you all with me? Right? So similarly, if it is XYZW, W is there in units place, Z is there in tens place, Y is there in hundreds place, X is there in thousands place. So it is 1000X plus 100Y plus 10Z plus W. I hope this is very clear to you. Here Y and X are called the digits. Here Y is X and Z are called the digits. X is there in hundreds place, the value of X will become X into 100. I hope this key point number 1, it is clear. Now, key point number 2. Key point number 2. Listen carefully. Key point number 2. Let me take a 2-digit number, XY. By default, it is in base system 10. Y is there in units place, X is there in tens place, so it is a 10x plus Y. It is a 10x plus Y. Now we will discuss the divisibility rule. We will discuss the divisibility rule for 2, 5. We will discuss the divisibility rule for 2, 5. I took a 2-digit number XY in base system 10. Let me take a 3-digit number XYZ in base system 10. Z is there in units place, Y is there in tens place, X is there in hundreds place. So it is XYZ base system 10 is 100X plus 10Y plus Z. Listen carefully, beta. Suppose if XYZ base system, XYZ in base system 10, if this is divisible by 2, if this is divisible by 2, that means left hand side it is divisible by 2. 100 is anyway divisible by 2. 10 is anyway divisible by 2. Z should be divisible by 2. Z should be divisible by 2. If XYZ is divisible by 2, that means Z should be divisible by 2. Z should be divisible by 2. If XYZ is divisible by 2, that means this is an even number. 100 is an even number. Even into any number, even. Even into any number, even. This should be an even digit. That means Z should take an even digit. Z should take an even digit. What are the even digits possible? 0, 2, 4, 6 or 8. If you are writing natural numbers starting from 1, if it is ending with 0, 10 is even, 20 is even, 30 is even, right, 40 is even. So 0 is also considered. If XYZ base system 10 is divisible by 2, that means this will become an even number. This is an even number. 100 contains 2. 2 into any number, it is an even number. This is also an even number. Even plus even, even. This should also be even. That means Z should be an even digit. For a digit to be an even digit, Z should take 0, 2, 4, 6 or 8. Z should take 0, 2, 4, 6 or 8. That means what is the divisibility rule for 2? Divisibility rule for 2 suggests that unit digits can take either 0, 2, 4, 6 or 8. If the unit digit takes any of these values 0, 4, 2, 4, 6 or 8, that means it is taking an even digit. It is taking an even digit. Right? I hope this concept is clear. Divisibility rule for 2, it is clear. Suppose if XYZ base system 10 is divisible by 5. If XYZ base system 10 is divisible by 5, this is divisible by 5, 100 is divisible by 5, 10y should be divisible by 5. That means Z is nothing but the unit digit. Z is nothing but the unit digit. Unit digit should be divisible by 5. 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 That means Z can take how many values? Either 0 or 5. If a number is ending with 0, 20 is divisible by 5, 30 is divisible by 5, 35 is divisible by 5. For a number to be divisible by 5, unit digit should be divisible by 5. For a number to be divisible by 2, unit digit should be divisible by an even digit, which is 0, 2, 4, 6 or 8. I hope the divisibility rule for 2 and 5, it is clear. Suppose if I take a combination of 2 and 5, that is 10 is nothing but 2 into 5. 10 is nothing but 2 into 5. That means unit digit for the divisibility rule of 2 is 0, 2, 4, 6, 8. For 5 it is 0 or 5. What is the intersection of these? What is the value that is common in both? 0 is common in both. That means what is the divisibility rule for 10? Divisibility rule for 10 is unit digit should be 0. Unit digit should be 0. I hope the idea it is clear. Why the unit digit should be 0? Because to get the divisibility rule of 10, I took the divisibility rule of 2, then I took the divisibility rule of 5, then I did an intersection of the possible unit digits. 0, 2, 4, 6 or 8, 0 and 5. The element which is common in both 2 and 5, it is nothing but 0. Very, very important key point 2. In key point 2, we discussed the divisibility rule for 2, for 5 and divisibility rule for 10. Key point number 2, I hope it is clear. Next comes key point 3. What is key point 3? Let us discuss key point number 3. Divisibility rule for 2 we have seen. Next let us take 2 square 4. Next let us take 2 cube 8. Next let us take 2 power 4 16 and so on up to 2 power k. What is the generic divisibility rule for 2, 4, 8, 16, 32, 64 and so on for 2 power k? Now let us see the concept. Once you understand the concept, all the problems are very easy. Let me take a 3-digit number, XYZ base system 10. X is in hundreds place, 100x. Y is in tens place, 10y plus z. Am I right? If XYZ in base system 10, if it is divisible by 4, if the left hand side is divisible by 4, these divisible by 4, 100x is divisible by 4. 100 is 4 into 25. 28 is nothing but 12 plus 16. This is divisible by 4. This is divisible by 4. This should be divisible by 4. 10y plus z should be divisible by 4. 10y z is nothing but the last 2 digits of a number. Y is there in tens place. 100x is divisible by 4. If xyz in base system 10 is divisible by 4, this is divisible by 4. This is divisible by 4. 10y plus z should be divisible by 4. 10y plus z is nothing but yz. That means yz should be divisible by 4, or in other words, last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. Suppose if I take xyzw in base system 10, suppose if I expand units, tens, hundreds, thousand, 1000x plus 100x, 1000x plus 100y plus 10z plus w. If xyzw in base system 10, if this is divisible by 8, if this is divisible by 8, 1000 is 125 into 8. This is divisible by 8. This entire number should be divisible by 8. That means yzw should be divisible by 8. Yzw should be divisible by 8. Yzw is nothing but last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. I hope you are understanding something from this key point 3, right? Divisibility rule for 2 is 2 power 1. Power is 1. Only unit digit should be divisible by 2. 4 is nothing but 2 square. Power is 2. That means the last 2 digits should be divisible by 4. 8 is nothing but 2 cube. Last 3 digits should be divisible by 8. 16 is nothing but 2 power 4. Last 4 digits should be divisible by 16. 2 power k. Last k digits should be divisible by 2 power k. Last k digits should be divisible by 2 power k. Extremely important key point. Once you understand this, right, then the concepts are very easy. There is a number and there is a divisibility rule. We will determine the number and also the divisibility rule of that number. Number is 2. That means unit digit should be divisible by 2. Unit digit should be divisible by 2. If the number is 4, 4 is 2 square. Last 2 digits should be divisible by 4. If it is 8, 8 is 2 power 3. That means last 3 digits should be divisible by 8. If it is 16, 16 is 2 power 4. Last 4 digits should be divisible by 16. If it is 2 power k, last k digits should be divisible by 2 power k. Last k digits should be divisible by 2 power k. I hope the idea it is clear. We are finding the generic form of the divisibility rule for 2 power k. 2 power 1 means unit digit should be divisible by 2. 2 square means last 2 digits should be divisible by 2. 2 cube is last 3 digits should be divisible by 2. 16 is last 4 digits should be divisible by 16. 2 power k means last k digits should be divisible by 2 power k. I hope the idea is very, very clear how to determine the divisibility rule for 2 power k. Then we will discuss 3 power k. Then we will discuss 5 power k. 2 power k, 3 power k, 5 power k. Right, we will discuss. Next one. Key point number 4. Key point number 4. Key point number 4. Divisibility rule for 3, 9, 27 and so on. Divisibility rule for 3, 3 square, 3 cube and so on up to 3 power k. Again we will see the concept. Suppose if I take x, y, z in base system 10, x is there in hundreds place, 100x, y is there in tens place, 10y, z is the units place. So these are nothing but 99x plus 9y plus x plus y plus z. X plus y plus z. These x, y, z in base system 10. Now if you observe here, if this is divisible by 9, if the left hand side is divisible by 9, 99 is 9 into 11 divisible by 9, these also divisible by 9, x plus y plus z should be divisible by 9. X plus y plus z should be divisible by 9. I hope the idea it is clear. Now these 9 out, 3 it is nothing but, now see here, if the left hand side is divisible by 3, 99 it is divisible by 3, 99 it is divisible by 3, 9y, this is also divisible by, right, 3, x plus y plus z should be divisible by 3. 3 and 3 square, I hope it is clear. 27, there is a divisibility rule. 27 into 37 is 999. So there is a divisibility rule. 10 cube by 27 is equivalent to 1. When the time comes, I will discuss that one. Similarly, for 3 power 1, we will use Euler's theorem. That are all little advanced concepts. Now we will discuss the basics. Divisibility rule for 3 and 3 square. If xyz base system 10, if this is divisible by 3, 99 is divisible by 3, these also divisible by 3, x plus y plus z should also be divisible by 3, x plus y plus z should also be divisible by 3. I hope the idea is crystal clear to you. That means, what is the divisibility rule for 9? What is the divisibility rule for 3, 9? Divisibility rule for 3, 9 is sum of the digits should be divisible by 3 or 9. Please make a note of it. Divisibility rule for 3 and 9 is sum of the digits should be divisible by 3 and 9. Key point number 4. I hope the idea it is clear. Divisibility rule for 9 is sum of the digits should be divisible by 9. If it is for 9, all the factors of 9 also will obey the same principle. The factors of 9 are 1, 3 and 9. After 9, the largest factor is 3. So the sum of the digits should also be divisible by 3. So we are restricting our fundamental class to 3 and 9. 27, 10 cube divided by 27 is 1. 81, what we will do is, we will use Euler theorem and some more concepts which are related to the 10 power k divided by 81 is plus or minus 1. So that is a little advanced level. Let us restrict to 3 and 9. I hope these key point number 4 is clear. What is key point number 4? Sum of the digits should be divisible by 3 or 9. Sum of the digits should be divisible by 3 or 9.